Right, so in this example, we're still looking at a back titration or indirect titration, and this is just another example. So this time we have some insoluble salt, and the only way to dissolve it is by dissolving it in acid, but we want to determine its concentration in a sample. So we're told we need to determine the mass in grams of calcium carbonate. So let's just write that. So it's calcium, CaCO3, present in a 0.125 gram sample of chalk. So as always, if we think about this, so we have a sample of chalk. This thing in total weighs 0.125 gram, and then a certain percentage of it or a certain section of it is calcium carbonate, and the rest of it is something else. Who knows? Else. Right. So that's the idea in our head. We want to determine what the mass is of the calcium carbonate in that situation. And it should be less than 0.125. We're told that the chalk is then placed in a conical flask and added 50 milliliter of hydrochloric acid using a pipette. So that's just information to tell us that the volume will be exact. The excess HCl was then titrated with sodium hydroxide. The average sodium hydroxide used was 32.12 milliliter. We want to calculate the mass of calcium carbonate in grams present in the chalk sample. Okay, let's draw a picture. You're probably tired of this by now, but it always just helps. So a conical flask, it is not, so a conical flask, no, that's a bad conical flask. That is a better one, but more diagrammatically correct almost. So in this we place our sample. So this is the sample, the 0.125 gram sample. All right. And to that, we add 50 milliliters. So we add in a pipette, okay, I'm not going to draw the pipette this time again. We add 50.00 milliliter of HCl, which also has a concentration, let's call it concentration HCl, equal to 0.200 molar. All right, so that's what happens. And of course, the HCl is going to react with the calcium carbonate. And when you have a strong acid reacting with a carbonate, what forms? A gas. You have a gas forming reaction. But that's information for later on. We first need to look at the excess HCl was then titrated with whatever. So if we look at our timeline, so what happens next is there's going to be excess HCl, and that is then titrated. So we want to titrate the excess HCl. So we have a little burette thingy, and let's see if I can draw a better conical flask. Yeah, that's much better. Which has now, at the moment, it has some solution that contains an unknown amount of HCl, because it's an excess. There's a lot of other stuff. There's the CO2 has evaporated. There's water. There's calcium chloride, but that's all in solution. What we add to this is we add 32.12 milliliter of sodium hydroxide. Which has a concentration of 0.25 molar. Okay, so where do we start? We start from the right-hand side. So we're first looking at the titration. And during the titration, What do we determine? We determine the amount or the concentration of the analyte in this case being the sodium hydrogen chloride. Then how do we do that? We need to relate the amount of sodium hydroxide to the amount of HCl. And to do that, we also need the chemical equation. So remember, you always need to write something like the chemical equation for the titration reaction is given by HCl in aqueous solution plus sodium hydroxide, also in aqueous solution. This is a strong acid and a strong base, so it's strong product forming. And that's not too important now. It forms sodium chloride, exchange reaction, so sodium goes somewhere, chlorine goes somewhere. Well, not actually the chlorine, the hydrogen goes somewhere, but anyway, you exchange everything. You should be fine with that concept by now. Aqueous plus water. Strong acid, strong base forms a salt plus water. All right, and this is balanced. So we will know that it's 1:1. So if we know the amount of sodium hydroxide, we immediately know the amount of HCl. So we calculate the number of moles of sodium hydroxide, and that's going to be equal to the concentration of sodium hydroxide times the volume, and this is then equal to 0.250 mole per liter times 32.12 times 10 to the negative 3 liter will then give you a value of 8.03 and some numbers times 10 to the negative 3 mole. And we know from the reaction equations, now you write a little sentence that says HCl reacts in a ratio to sodium hydroxide of 1:1, therefore 8.03 times 10 to the negative 3 mole sodium hydroxide will react with 8.03 times 10 to the negative 3 mole HCl. You can just say here number of moles of HCl. This is in the titrant. This is in the titrant, so that's the amount. Okay. And how do we get the amount of HCl that reacted with the calcium carbonate? Well, we first need the amount of HCl added. So in other words, how much did we put in this flask at the beginning? That's not the concentration. I want the moles. Is equal to the concentration times the volume added, and that will be then 0.2 times 50. Okay. This should give you a value of, if I can turn this page, then I will get the value. Added is 0.010 mole. Okay. Does that make sense? Yeah. That gives us the total amount added. In other words, the number of mole of HCl reacted initially, or reacted with the calcium carbonate, however you want to call it, is going to be equal to this total 0.01 minus the 8.03 times 10 to the negative 3, should then give you a value of 1.97 times 10 to the power minus 3 mole. Okay, so now we know how much HCl reacted in the first place. And how can we relate that to the calcium chloride? Well, we need the reaction equation again. So HCl in the aqueous state was added to calcium chloride, calcium carbonate, also in, this is, it's not in the aqueous state, it's in the solid state, to form, well, this is HCl with a carbonate, so a strong acid with a solid metal carbonate, that will form a salt, gas, and water. The salt, can you see it, is going to be calcium and chlorine, and that means it needs to be Cl2 because calcium is 2 plus, and chlorine is 1 minus, and we swap places like this. Whoops. And then in principle that goes there, so it forms H2CO3, and remember that decomposes then into, this will be aqueous, and then decomposes into CO2 gas plus water. Question is this balanced? Answer is no. We need two Cl's. Right, two Cl's. Calcium is balanced. Carbon is balanced. Oxygens 3 and 3 balanced. Hydrogens 2 and 2 balanced. Okay. So that means, remember now you write out a nice sentence, 2 HCl reacts with 1 calcium carbonate. That means what? If this is, let me write it out because I know this is something you might struggle with. So 2 mole HCl reacts with 1 mole calcium carbonate. Therefore, 1.97 times 10 to the negative 3 mole HCl will react with how much calcium carbonate? Well, what you need to get is you need to write a sentence essentially where you have 1 mole of everything. So you divide by the highest number, or if you have weird numbers, then you multiply by reciprocals. Will react with a half times 1.97 times 10 to the negative 3. All right, mole calcium carbonate. If you struggle with it, you can remember you use that little thing where it's 2 to 1. You want to know how much this one is. You have a number here. In other words, x is then equal to alpha over 2. But you need to write out the words. You need to write the words. You can't just say x. What is x? X is potatoes, or that doesn't make sense. So you can use that to just figure out what you need to multiply with, but you write out the formal wording as such. And then we can just say, therefore, the number of moles of calcium carbonate equal to this half times that thing. So it's going to be 9.85 times 10 to the negative 4 mole. No, there's some numbers there still. Okay, but what were we asked? We were asked the mass of the calcium carbonate. So therefore, finally, the mass of calcium carbonate, the molar mass is gram per mole. Moles, so in other words, we want to get rid of the moles. So we say the number of moles of calcium carbonate multiplied by the molar mass of calcium carbonate is equal to the molar mass of calcium carbonate is 100.09 grams. So it's 100.09 gram per mole. So just so you know where my numbers are coming from. So it's equal to 0.099 gram. And just check my significant figures. Actually needs to be 3 significant figures. So it's 0.990 gram. All right. Therefore, and then you're right. Hence the mass. Hence, comma, the mass of calcium carbonate in the sample is 0.0990 gram. Check me up about that last number. I might be wrong about it, but I mean, you should be fine once you get to that point. Okay, that is back titrations. I hope it's not too difficult. It essentially just adds an extra step. All of these things are the same. You work out the number of moles of everything, and eventually you end up with an answer. So that's all in stoichiometry. Stoichiometry, you're given some information, you work out the moles, you use the chemical equation to get all the moles of anything else that you're interested in, and from that you can get masses, concentrations, and whatnot. All right. I hope this helps, and at least offers some additional practice with these kinds of things. All right. Thank you for watching.